Okay. So when we left off, we had this app with our custom view, which we can scroll through and we can see all of our custom cells in our table. Now we're going to make some changes to the way we fetch data to this from this. So currently, we don't really have a very complex data structure. We have this idea of a flock, which contains a list of strings, which is fine when we don't have anything more complex than strings to represent, but we're starting to get to the point where we have a data object that we want to manage, a bird object. So what we'll do now is we'll create our custom object, and then we'll create a service that will provide that object to our view. So you'll want to hit File, New, File, and this time we're going to be making a Swift file. I'm going to name mine Bird. Great. So you can see now that unlike the Cocoa Touch classes, when we make a Swift file, we don't get UIKit imported. Instead, we get Foundation imported. What we're going to do is we're going to make this bird a class. There is no base object that you have to inherit from with Swift. So what attributes do I want my bird to have? Well, I want my bird to have the attribute name, and that's going to be a string. And I want my bird to have the attribute description, and that's going to be a string. Great. And now it says that my class bird has no initializers, so I need to make an initializer that will allow my bird to be created with these attributes. So we'll do that like this. We'll do name, string, description, string. Now, in Swift, when we make a method like this, we can have argument labels and parameter names, which means that when you are calling the method, you can have this name appear in the call and then this name appear in the implementation. So for example, when I call this method like this, I would get bird named beat. But here, when I assign him, I use the parameter name, even though in the call, I use the argument label. If I do not provide an argument label, then it's assumed that the argument label and parameter name are the same. And that argument label will be required. If instead I put an underscore, then that means that the argument label is not required, and I can call the method like that. Okay, so for this, I think it would be good to have an argument label of named. And then description, we'll just leave description. Self.description, description. Beautiful. So now we've set our attributes. And we have our little bird class. It's beautiful. Now, in our bird list view controller, rather than our flock being an array of strings, we're going to make it an array of birds. Like that. And it might take Xcode a second to catch up with me. There we go. So now it recognizes bird, and it's upset now, of course, because that isn't a bird. So it's saying, cannot convert value of type string to expected element of type bird. That's fine. We'll make some birds. So let's make a bird named Oriole with a description of he's angry. And let's make a few of these. Now let's do a blue jay. Blue jays are customarily very angry. Blue jays, fun fact, are some of the most territorial birds in the world. They will chase down bobcats, animals way bigger and fiercer than they are, to protect their nests, and they will keep hounding those animals even after they have run away. Let's see, what else? Let's go with an eagle. They have a very intimidating appearance, but they actually don't move around that much. Great. Now, for the purposes of example, we'll just do these over and over. So now we have a collection of birds. That's good. So the next thing that we have to change is where we get information from our flock for our bird name label. Now, the thing that this is returning is a bird and not a string. So let's save that off. Let's say let current bird be that bird. And let's assign the name label to that bird's name. Let's also go ahead and assign the description to that bird's description. Let's run the app and see what we get. Great. Oh, look at that. He really nothing. This should say he really angry. And now, because it'll take only 2 seconds, we're going to fix that. Beautiful. All right, so while that loads up, this is starting to look good. But what I'm noticing is that we now have some code in here that's starting to look pretty big. We're starting to end up with a case of massive view controller, which is a term that iOS developers use to describe when all of the logic for a program lives inside of the view controllers instead of objects that are designed to manage some of the other pieces of the application. Beautiful. All right. So we're going to start to separate some of this logic into its own object. And in particular, for now, we're going to make an object called bird service. A service is an object that's responsible for bringing us data from somewhere outside of the application, like an API or another application sometimes. Sometimes a service that is specifically designed to get data out of a database will be called a repository. But for this, we're going to put this in a method on a service. So what I'm going to do is I'm going to cut out my array, and I'm going to say that this will come from our bird service, which will get the birds. So that's the method we're going to make. Let's go ahead and make an attribute in here for our bird service. Now, once again, I'm going to force unwrap it, And I'm going to do that because without a way to get birds, my app doesn't mean anything and it might as well crash. But I understand that this force unwrapping makes me responsible for ensuring that the bird service is there. Here in View Did Load, we'll go ahead and set the bird service. And for now, what we'll do is we'll initialize it like that. We'll talk more about this choice a little bit later. Now, Swift is right. We're using an undeclared type called bird service. And the reason that we're doing that is because we have not made our bird service class yet. So let's do File, New, File. We'll make it a Swift file. We'll call it bird service. Great. So we need a class called bird service. And right now it needs one method, func get birds. And that method is going to return an array of birds. And what we'll do is we'll return that array of birds. So now our view controller doesn't have a list of random birds in it. So we'll give Xcode a second to catch up. I don't know if it helps, but sometimes I do go ahead and run a build, and that seems to sort of help the system catch up to me. It's not usually quite as slow as it is right now. It's just that when I have my live streaming software running and Xcode and the simulator running, it's a little slow. Great. So now we are maintaining the role of the view controller as a central hub for all of the other objects to get data to the view, which is nice, and that's what it's for. We're going to do one final refactoring here before we finish this off, and that's going to be to move some of these files into groups that will allow us to more easily find them when we're looking for things. So we're going to say File, New, Group. And I'm going to call this Bird Management. We might decide to change the way that we do this later. So now I'm going to take everything that manages my bird data, like bird service, and the bird class itself, and I'm going to stick them inside of bird management. Now, this particular variety of organizing things is called domain-oriented organization. And that's when each slice of your app from beginning to end has its own folder. So you'll see this frequently in Spring applications where there's a folder that holds everything related to users, a folder that holds everything related to accounts, a folder that holds everything related to products, if it's an e-commerce app. You can also slice it the other direction, which is what you would see in a Rails application, where you have a folder called controllers, and all of the controllers go in there. A folder called views, and all the views go in there. A folder called DB, and your database stuff goes in there. So you can organize your application according to the problem domains that it deals with, or according to the different layers of the application. And we generally think of that layer-based organization as horizontal organization, and domain-based organization as vertical organization. So then we also have these views and stuff over here. In fact, let's go ahead and try that horizontal organization to see what we think. I'm going to delete my bird management group. I am going to make a new group. I think I have to click on this. File, New, Group. And let's do Views. And let's put our new bird cell in Views. And then let's do File, New, Group, Controllers. So fun fact, these folders don't actually change the organization of the iOS app under the hood. They only change what you see when you're looking at it in Xcode. So I'm moving my bird list view controller into controllers, file, new. I have to click on Angry Birds target, new group. And for this one, we'll do data, bird service, bird. So in Xcode, these sort of folder things are really only for your benefit. It doesn't actually change where your files are located within iOS's understanding of this code. I think I kind of like that better for now. I think the reason I like this better is that we don't really have multiple concerns in our application. If we had a bunch of different data models, that would be one thing, but we really only have one right now, and that's bird. So I'm going to leave it in this horizontally oriented organization for now. I'm going to go ahead and leave the default files out here for now. Now, let's make a commit. So what we'll do is we'll say serve birds. Serve bird data model from a service class. Bird attributes now populate. Custom cells. Cool. Alrighty. See you in the next one.